Okay, so I have this problem here where a car travels 20 kilometers due north and then 35 kilometers in a direction that is 60 degrees west of north, so to the left. We want to graph this and find the magnitude and direction of a single vector that gives the net effect of the car's trip. So what we're wanting to do is we're wanting to add these two vectors together and find the resultant vector. So the first thing that I'm going to do is I'm going to draw a little graph here, right? Let's put our cardinal directions on here, north, south, east, west, and then I'm going to draw the vectors on here first. So we know that initially this car travels 20 kilometers due north. I'm going to call that vector A. Then my car is going to go 35 kilometers in a direction that is 60 degrees west of north. So if I'm going north, I want to go 60 degrees to the west of north. So this would be 60 degrees, and I'm going to call this vector B. So what we're wanting to find is this resultant vector here that represents the total displacement of my car. Now that I have this picture drawn, I'm going to take the information in the picture and I'm going to write it down. So I know that vector A has a magnitude of 20 kilometers and it is moving at an angle of 90 degrees. Keep in mind, we're thinking about our angle going from the 0 on your unit circle. So this angle here is going to be 90 degrees. For vector B, it has a magnitude of 35 kilometers, and the angle of B is actually going to be 60 degrees plus 90 degrees, right? Because we want this entire angle here. So 60 plus 90, that's going to be 150 degrees. Now that I have this information, in order for me to add these together, I want to take it from polar coordinates and I want to put it into Cartesian coordinates. So in order to do that, I want to think about a right triangle. So if I have a right triangle, right, I have the x component on the horizontal, the y component on the vertical, and the magnitude of that vector is going to be my hypotenuse. So I can use sine of theta, cosine of theta, and tangent of theta to determine what the x and y components of each of these vectors is. So for sine, right, this is going to be the opposite, so the y component over the hypotenuse, which is my magnitude. Cosine is going to be the x component over the magnitude, and tangent is going to be the y component over the x component. So if I'm wanting to find the x component of vector A, I'm going to want to use cosine, but I'm going to rearrange this so that the x component is on the left-hand side. So I use r here just generally to represent a vector, but I'm going to want to be more specific whenever I'm looking at the x component of vector A. So generally, right, if I'm wanting to rearrange this, I would have Rx is equal to the magnitude of my vector times cosine of theta. When I'm thinking about my A vector, this is going to be the magnitude of vector A times cosine of the angle that A has. Just visually looking at this, I can tell that the x component of A is going to be 0 because, right, if I have the x, y coordinates, all of vector A is going in the y direction. There's no aspect of it that's moving in the x direction. So I can just look at this and tell that the x component of A is going to be 0. I can also do this mathematically though, right? I could plug in that the x component of A is going to be equal to 20 kilometers times cosine of 90 degrees. Cosine of 90 degrees is going to be 0, so we get that the x component of A is 0. If I want to get the y component, I'm going to do a similar thing, but this time I will have that the y component of A is going to be equal to the magnitude of vector A times sine of theta A. Since all of this vector is going in the y direction, I again can just look at this and see that the y component of vector A has to be 20, but I can also do this mathematically, right? Again, we have the magnitude of A is 20 kilometers. We would have sine of 90 degrees, and sine of 90 degrees is 1. 1 times 20 kilometers is going to give us 20 kilometers. So I now have the x and y components of vector A. I need to do the same thing with vector B, right? So the x component of B is going to be equal to the magnitude of B times cosine and that angle that B makes. This is going to give us 35 kilometers times cosine of 150, which is going to be negative 30.3 kilometers. Right away, I know that this is probably correct because I have a negative value for my x. And if I look over here at this vector, my vector is on the negative x side of my coordinate system. Now I need to, I'm going to go ahead and dot that into a box. Now I need to find the y component. So the y component is going to be the magnitude of b sine of theta b, and we will get 35 kilometers sine of 150 degrees. I should expect this to be a positive value, right? Because it is above the 0. It is in the positive y direction. And I get that the y component of B is 17.5 kilometers. So now that I have this in the Cartesian coordinates, I can add it together. But I'm going to rewrite this because it looks a little bit messy. So I had that the vector A is going to be 0 in the x direction plus 20 kilometers in the y direction, and I had that vector B is going to be negative 30.3 kilometers in the x direction and 17.5 kilometers in the y direction. Now, to get the resultant vector, I want to add these together. And I have to add like with likes, right? So I have to add the x with the x and the y with the y. This means that my resultant vector is going to be equal, let's do the x component. So the x component of my resultant vector is going to be the x component of A plus the x component of B. This means that the x component is going to be 0 plus negative 30.3 kilometers. So the x component of my resultant vector is going to be negative 30.3 kilometers. And I want to do the same thing to get the y component. That shouldn't have a vector sign since that's only an x component. So for the y component, I have the y component of A plus the y component of B. This means that the y component of my resultant vector is going to be 20 kilometers plus 17.5 kilometers, and I will get that the y component is 37.5 kilometers in my y direction. So the resultant vector is negative 30.3 kilometers in the x direction plus 37.5 kilometers in the y direction. But because this information was given to me in polar coordinates, I should probably translate this back into the polar coordinates, meaning that I want to find the magnitude of this vector, and I also want to find the angle of this vector from 0 degrees on my unit circle. So we can use the Pythagorean theorem, right, where c squared equals a squared plus b squared. In this situation, we would have that the resultant vector squared is equal to its x component squared plus its y component squared, right? And this is my magnitude. So the magnitude of this vector is going to be the square root of its x component squared plus its y component squared. And then I also need to figure out what the angle is. Since I have the x component and the y component, I can use tangent of theta is equal to y over x, and I would want to take the tangent, the inverse tangent of this to get the angle. So the magnitude of this vector is going to be negative 30.3 squared plus 37.5 squared. And that's going to be 48.2 kilometers, and my angle is going to be tangent inverse of 37.5 over negative 30.3. This actually gives you negative 51 degrees, but that doesn't make sense, and because of this being a tangent function, I'm going to add 180 degrees to that, meaning that my angle is going to be 128.9 degrees. So my vector r, right, the resultant vector, the total displacement of this car is 48.2 kilometers at an angle of 128.9 degrees. And if I wanted to plot this out, right, I would want to go, this is 180, this is 0, this is 90, 128 would be in this direction, and 48 would be out this way. This does indeed look like the resultant vector I expect from my visual drawing that I made. So this would be the solution.